Hello, everyone. This is Dr. Fu from Hofstra University. So in this short video, I will quickly go over the 3 challenges in the category of Linux basics. Most of the challenges are pretty easy. They can be tackled by freshman students. Well, let's look at our first challenge. So basically, we are required to figure out a file contained in this folder of the Kali Linux. And we want to figure out which is the file which has the X-bit set. So this can be accomplished easily using a file list command in seconds. Let's get to the Kali Linux of the competition site. So you might immediately notice that this file has a different color because its X-bit is set. So this is the solution for the first challenge. All right, so let's go ahead to our second challenge. So the second challenge in this category is we need to run a file contained in this folder, and we want to figure out what is the message printed by this executable file. So in this case, you might notice that the X-bit of this file is not set yet, so we could simply make it executable by setting its permission bits. And then let's just run it. So apparently this is a solution to the second challenge. So this is also a very easy question. As long as you know about Linux, you should be very well able to solve the problem. Now let's look at the next challenge in this category. So for this challenge, we have a file called server, which is a vulnerable telnet server, which has some bugs in its implementation. So somehow, when fed with a pretty large data payload, it crashes with a call dump. All right, so we need to find out the flag contained in the attack payload. So basically, this challenge needs a little bit of skills of the debugger, because with the call dump, with a debugger like GDB, you can easily figure out the memory snapshot of the crashed process. So let's switch to the Kali Linux again. So in this case, we have a call dump file. We have the vulnerable program, and want to debug this program given this call dump. So at this moment, this is the instruction which crashes. Basically, what it does is that it takes the value of the REX register and it tries to save a 0 into that address. Now, if this REX is a kind of like a dangling pointer, and then if it's an invalid address, then we will have a segmentation fault. To verify, if you print out the value of REX, you can see that that's an invalid number as an address. Now, so the question is that how do we figure out what is the payload that leads to this crash? we need a little bit of information about the source code. But the source code itself is not available, so we have to analyze the assembly code. Well, in this case, usually what we would do is that maybe dump 20 or 30 instructions before this crash point and see that what are the functions placed before this crash point. So we are guessing with an offset like 34 bytes, and then can we dump 30 instructions from that address? So again, this is where we have the dangling pointer crash. And you can see that before this point, there's a call of a string, which is basically just like a find string operation in a Java language. So we are searching a smaller string contained in a container string. Apparently, there's something wrong with this call when people feed it with a malicious input. So then our question is that, well, what are the input parameters for these functions? So we know that usually they are pushing to the stack, or they are pushing to, they are saved into some of the registers like RDI and RSI and so on. So we probably need to dump a little bit more instructions before this point. Let's try another offset and see that if we can get a little bit more instructions before the call. So in this case, you might notice that here are some of the memory address loading instructions, which sets up the parameters for the string. So let's try out one address here. This says that this is an address, which is the result of value of the RPP register minus the hex number 16800. So this is like a stack address, which is usually the address of a local variable in a stack frame. So let's treat it like a char star. So this is a string. The base register is RPP, and the offset is minus hex number 16800. So apparently this is the payload, one of the parameters passed through the string function. It started with a flag prefix, and then you can see that there's a repetition of a lot of counters. This is apparently an attempt to overflow a stack buffer for local function variables. All right. So again, this apparently is the solution for the lost challenge in the Linux category.